Hey there, welcome to the Explainer. Today, we're jumping into a type of problem that can look, well, pretty intimidating at first. Radical equations. But trust me, by the end of this quick explainer, you're going to have the master key to unlock any of them.
So here's our game plan. First, we'll look at the puzzle itself. Then, I'm giving you that 4-step master key. After that, we'll work through a few examples, I'll point out the common traps to avoid, and we'll wrap up with why any of this actually matters. Ready?
All right, first things first, the radical puzzle. What's the big deal with these equations? What makes them so different from other stuff in algebra?
Well, a radical equation is exactly what it sounds like. It's an equation where the variable, the x you're looking for, is literally trapped inside a radical sign. Usually that's a square root. And that's the real challenge, right? You can't just add or subtract the radical symbol to get it out of the way. To free that variable, you have to actually undo the root itself. And that takes a special trick.
Which brings us perfectly to our next section, and really the heart of this whole thing, your 4-step master key. This is the simple, totally reliable process that's going to crack any of these radical equations.
And honestly, the process is way more straightforward than you might think. Just burn these 4 words into your brain. Isolate, raise, solve, and check. First, you get the radical all by itself. Second, you raise both sides to whatever power gets rid of the root. Third, you solve the nice, simple equation that's left. And fourth, and believe me, this part is non-negotiable, you always check your answer.
So why is that check step so critical? Well, here's the thing. Squaring both sides of an equation is a super powerful move, but it can sometimes create fake answers. They're called extraneous solutions. They look right, but they don't actually work. Checking is your safety net. It catches the fakes every time.
Okay, enough talk. Time for section 3. Let's put this master key to work and see how it actually handles a few problems.
Let's ease into it with a basic one. We've got the square root of x plus 3 equals 5. And notice, step 1, isolate, is already done for us. The radical is already sitting there all by itself on the left side. Nice.
So we get to skip right to step 2, raise. We square both sides. On the left, poof, the square and the square root cancel out, leaving us with just x plus 3. On the right, 5 squared gives us 25. Now for step 3, solve. Just subtract 3 from both sides and boom, x equals 22. And of course, the final check, the square root of 22 plus 3 is the square root of 25, which is 5. It works.
Okay, let's level up a little bit. Here, the radical is not isolated. See, it's being multiplied by 3 and there's a 4 being added to it. So our first job is to clear all that other stuff away.
So we start with step 1, isolate. First, let's subtract 4 from both sides. That leaves us with 9 on the right. Then, we divide everything by 3. Now look, we have a nice clean equation. The square root of 2x minus 1 equals 3. From here on out, it's the exact same process. Square both sides, solve for x, and you get your answer. X equals 5. A quick check proves it's the real deal.
All right, time for the advanced example. I kind of think of this one as a little detective story, because there's a twist coming. We have the square root of x plus 5 equals x minus 1.
So the radical's already isolated. That's good. We square both sides, but whoa, look what happens. When you square x minus 1, you end up with a quadratic. When we get everything over to one side, we have a quadratic equation that we can actually factor. And this gives us 2 potential solutions, 2 suspects in our mystery. X equals 4 and x equals negative 1.
And here's where the plot really thickens. We've got 2 candidates, but are they both legit, or is one of them an imposter?
This is the moment our check step becomes the hero of the story. Let's plug our 2 suspects back into the original equation. First, x equals 4. We get 3 equals 3. Perfect. That's a valid solution. Now let's try x equals negative 1. Uh-oh, we get 2 equals negative 2. That's just not true. This is our extraneous solution, that false lead created by squaring the equation. So the only true answer is x equals 4. Case closed.
You know, that last example leads us perfectly into our next section, how to avoid the common pitfalls. Let's talk about the 2 biggest mistakes that can really trip you up.
And here it is, the #1 mistake people make, hands down, squaring before they isolate. Just look at the difference. On the left, if you square right away, you create this messy, complicated disaster. But look at the right. When you take a second to isolate the radical first, the solution is clean, simple, and fast. So please, always isolate first.
Okay, let's just hammer this home. 3 things to remember. Number 1, always, always, always isolate that radical first. That's job 1.
Number 2, always check your final answers back in the original equation, no exceptions. And number 3, just remember that squaring, while useful, can create those sneaky fake solutions that look real but aren't.
So, let's wrap this all up. Why should you care about this stuff beyond the next test? Let's connect it to the real world for a second.
Well, look no further than the good old Pythagorean theorem. You know it, right? To find the longest side of a right triangle, the formula itself is a radical equation. This isn't just a problem in a textbook. It's used every single day by people in construction, navigation, even video game design, anytime they need to find the shortest distance between 2 points.
So today, you learned more than just a 4-step process. You really learned how to be a math detective, how to spot a fake solution that's hiding in plain sight. And it kind of makes you wonder, right? What other hidden traps are just waiting to be discovered in the world of algebra?